So, well, I was thinking about giving at the very beginning like a number of stories. This is I already did. I don't like to do presentations where I just present. This is not me. So this is like kind of standard Google presentation, but I added a bit of things that we are doing here in Warsaw. And the most important part is I want to hear questions. If you don't ask questions, I feel lost because perhaps I'm saying things that are making no sense. I simply don't know. Okay. As I said, I was with Microsoft before, working in search for many, many years. I had my startups at the very beginning, 3 of them. 2 of them were like, I was not having money to buy the food for real, because I was putting all the money in the startup. And we were doing data science in '98 when this term was not there yet. But of course, machine learning is way older than that. Now I'm in Warsaw, not far away from here. I run a site where there are like 200 engineering. We are running like crazy. This year we will be 300 people. We do a lot of machine learning, and we are coming from all the world. I'm Italian. I was living for many years in London and then many years in Amsterdam. Now it's 2 years that I'm in Warsaw. We do a lot of machine learning. I have an example of things that we are doing, but for optimizing the internal infrastructure of Google. We do also some machine learning for the outside world. I cannot answer all the questions. I need to say this, sorry. Don't push me too hard, because in general I tend to say things, and that's something that is actually backfiring on me frequently. So sorry for that. But I'm always available if you want offline to have a discussion a bit more technical, please. Okay, because this is something I enjoy, yes, because it's good, but I enjoy also way more technical conversations. Well, this is, I started with a classical thing. This is what Google is. Many, many years ago, in '97, Larry Page and Sergey Brin came with this. And I like a lot because the word information was there since the very beginning. Information is there. Right? Of course, you know Google. I don't ask how many times you use Google during the day. I have no idea. Probably above 100. I have no idea. Right now, I work in cloud. Why cloud? Because, of course, Google has a lot of technical infrastructure built over time, many, many data centers. You will see some data. I'm going to show you some data, what Google is doing on this. But I started with this because I found this really very interesting. Do you know what's this? Well, it's there, so what is this? Yeah, this is the first bill that Google paid. So Google started really, really very small. Google actually started in a garage that was rented by a Polish woman who is now the CEO of YouTube. And this was the amount of money. Of course, something else happened in the meantime, right? So in the meantime, there are 7 different products that are having, each of them is having 1 billion of users. And is there anyone that is not aware of any of this brand? Like, you know all of them, or should I clarify one of them? Okay. All these brands cannot be there without machine learning. I'll show you some examples as we go. But there is also another thing, that is the thing where I'm working right now. Google is organized in this way. Internally, we have something called technical infrastructure. And technical infrastructure is a kind of internal cloud where all these products are built on the top of them. So if you have search, if you have YouTube, there are a lot of things that are in common. In particular, there is something called Borg. And you can read a lot about Borg because Google has this policy, which is one of the reasons why I joined actually, that many, many internal results are published. So you can go there and search articles about Borg and what is Borg. Similar thing happened with MapReduce and many, many other examples, Spanner and so on and so forth. I think that this is very good because it's useful for the community. When I was not in Google, I was actually borrowing, in a positive way, I say this, many ideas from these publications. I really like this. Today, our cloud is serving 1 billion of users each day. Of course, this is our external customers. Now, this is, first, in my presentation, I shared some data about Google. This is our internal network. So this is basically the portion of internet that Google is actually owning. There are several hundreds autonomous systems for people who are aware of what is BGP and these kind of things. Can you guess what's the amount of traffic that Google is actually carrying? So if you take 100 is the whole traffic that is on internet, what is the traffic that Google is getting? You should be able to predict this. Drop a number. 30? 50? You said? 30. It's actually something around 25, 30, depends on the moment, of course. There are spikes. It's a huge number. And it's pretty much everywhere, including northern hemisphere and southern hemisphere. Then probably you also know some public contribution. I work a lot on this in the world of containers. Kubernetes is an open source project that became essentially the standard. I think that these numbers are old. It's not like there are 4,000 projects of Kubernetes. It's way more than that. I think that Kubernetes is one of the top projects in terms of star on GitHub. I think it's number 3, if I'm not mistaken. Can you guess what's number 1? So star on GitHub. It's in the first 3, correct. Okay. In Google internally, we serve 4 billion of new containers per week. So I want you to think about this a bit. These are all the computations that are running on Google. Take search, take YouTube. I don't know, perhaps someone is uploading, just an example of what I mean with this. Someone is uploading a video on YouTube. Well, we need to do transcoding in many different formats, many. And we need to optimize this. So one machine learning problem that my group is working on, and I can tell you some, during the presentation I will tell you some of the results that we have, but I cannot disclose how we are doing this, sorry for that, is exactly this problem. How to optimize the allocation of these 4 billion containers per week on the fleet. And you can imagine that even gain 0.2%, it's a huge amount of money, and it's way more capacity that you allow to other services. Right? How many people are using TensorFlow? How many people are using Keras? Can I understand what are the other, how many people are using PyTorch, for instance? What about other frameworks? Piano, of course. I started with piano myself. What else? Sorry? Cafe. Cafe. Cafe was good. I mean, my personal opinion on Cafe is that at the beginning it was like the only one where there were so many different models available. What else? Only you? 2 people? 3 people? Sorry? Okay. Why TensorFlow, if I may ask? Just a few, just to understand. Why are you using TensorFlow? Okay. Why Keras? Why Keras? Francois is a very, very nice guy to talk with. I started to talk with Francois when he was not even at Google. This was 3 years ago. No, 4 years ago, I think. And he was doing completely different things. He was actually painting, because that's what he likes to do. And I believe that he had like an impact on the community that is unbelievable. I think that all of us, we made progress thanks to his work. And he's a very humble guy, very, very humble guy. How many people are using GPUs here? Is there anyone that was able to use any TPU at all? That's bad. Any other accelerator? Okay, so you are only on GPUs. One thing I can do for you guys is Google has a programmer for giving access to GPUs. Well, we have two programs. One is a program for giving access to GPUs, and I can actually help a lot, so don't be afraid to reach me out. And the second one is, this is way more difficult to get, and the second one is to give access to TPUs. But I already did, for instance, here in Warsaw, I already did it twice. I already sponsored it. Okay. How many people are familiar with TPUs? At least you read something. So, is there anyone just raise your hand that perhaps may have an interest to play with TPUs? Okay. Reaching me out is very simple. My surname is Gulli. You can search my name, and my email is gulli@google.com. I want to share this video, and then I want to tell you a real story that happened to me.
My name is Abu. I am a high school student, 17 years old. People learn in different ways. For me, if I see something really cool, I'll try to take it apart and figure out how it works. It's a bit more extreme now because instead of it being hardware, I like to know how algorithms work. My freshman year, I remember Googling machine learning. Had no clue what it meant. That's a really cool thing about the internet, is that someone's already doing it, so you can just YouTube it and it's right there. The minute I really saw what machine learning can do, it kind of like hit something within me, this like need to build things to help people. My parents are immigrants from Afghanistan. It's not easy coming in. The only reason we made it through some of the times that we did was because people showed acts of kindness. Seeing that at an early age was enough for me to understand that helping people always comes back to you.
All right, everybody, listen up. Who's going to present today?
Machine learning is this concept that we can train computers to identify patterns in data and then use those patterns to predict off of new data. I have a quick demo. This is just some code that I wrote last night.
Miss Roscoe is the first teacher that I actually talked to about machine learning.
Abu and I first met his sophomore year. I was his Programming 1 teacher. My students do a computer science fair, and they are challenged to find a problem, but they have to use a form of technology to solve that problem.
And then it kind of hit me in a way where I could actually genuinely help people. Mammograms are the cheapest imaging format there is. It's the most accessible to people all around the world. But one of the biggest problems that we see in breast cancer is misdiagnosis. So I decided that that was going to be my project, build a system for early detection of breast cancer tumors that's accessible to everyone and that's more accurate. How was I going to do it? Machine learning. It's not an easy thing to do. Data is not publicly available, and if it is, it's low quality data. It's difficult. I wasn't even sure if I could do it. And I remember just thinking about like, everyone else is building a calendar, like maybe I should do that. But I was like, no, you got to do this. You need to.
He was talking to me about all the cool stuff he was doing, and I was telling him not to overdo it. He should just be a kid and worry about kid stuff.
The biggest, most extensive resource that I've used is this platform called TensorFlow. I've spent so many hours going really deep into these open source libraries and just figuring out how it works. Eventually, I wrote a whole system that can help radiologists make their decisions. All right, ready? Yeah. I'm by no means a wizard at machine learning. I'm completely self-taught. I'm in high school. I YouTubed and just found my way through it. You don't know about that kid in Brazil that might have a groundbreaking idea, or that kid in Somalia. You don't know that they have these ideas, but if you can open source your tools, you can give them a little bit of hope that they can actually conquer what they're thinking of.
Well, the reason why I like this presentation, this particular video, is because there is a sense in what we are doing that is behind science. So you can think this is a video like prepared video. It's a real story. It happened. So I want to share with you one story that happened to me, and this was last time I was talking with Roberto. I go frequently in San Francisco. When I got to San Francisco, this was happening to me last time that I was there, so around 3 weeks ago. I always like to take Uber because I like to talk with people, not because of the self-driving car. I like to talk with people. I like to connect with people. So I was really very late. It was my last meeting, and I was about to return to the airport, and I was really tired. When I go in US, I'm always jet lagged. So I jump on this Uber, and there is a guy. You can go and check my LinkedIn. I published this story on my LinkedIn. There is this guy, John, let's say John. And then this guy sees my badge. And then he says, you work for Google. Do you mind if I ask you a couple of questions? This is indeed the reason why I take Uber. So I started talking with this guy, and I was like, wow. Okay, so this guy told me his story. His story is like this. He has a background in chemical studies, but he has no idea what is data science. Around 3 months ago, his father died, and he died for a blood infection. Of course, this is not a subject where I'm any expert at all. And he told me that this type of blood infections are truly very common in US, and you can actually die in 12 hours if you are not able to do a very early detection. Now, to give a sense of what is the impact of this, there are 250,000 people dying every year in US for this type of infections in the hospital. And to give a sense of what is this is more than cancer. But it's way less known. So his father died 3 months ago. He said, I need to do something for this, like this kind of can do what to do. So I started to look at this problem, and then he came out to see basically something that was done by George Hilton. And basically, he started to use this. And now he's making his own startup using TensorFlow. So for like 1 hour and a half, we discussed about this problem. And I was like shocked because I knew this story. And that was another story that happened to me for real. And this guy was just, like not a proper data scientist, but he actually came with a solution. He showed me we are in touch right now. I made also some introductions to other people that I know. He asked some numbers that are actually worth the consideration. So there is an impact that we are having that is behind science, data science. Okay, so how many people are using Kaggle? Not that many. You know that Google has this free Colab access, and actually you can get GPUs for free there. That's a good question. Depends on. It's not like large. There are the basic free tier is limited, but again, you can contact me, please. Oh yeah, sure. Not many, but because people are not familiar with Colab, or because you don't think that this is useful? Okay, so the feedback was like, there is not enough resources available. Okay, this is something is known. Okay, it's not documented, understood. Other people are not familiar with Colab? Okay, if you don't mind, go and check, because it's available for free, and I like to have feedback on this. Of course, Google has a platform for artificial. Many of those things are. This is like kind of standard presentation. I believe that you are familiar with those things. How many people are not aware with at least one of the products that are here? Okay, what is the product? Just to understand, what's the product that you don't know? Okay, anyone else? Oh, you don't know Assistant. That's good. That's very, very... Okay, what is Cardbulk? Cardbulk is a very simple experience of virtual reality, where you take your smartphone and then actually there is a low-cost package that you need to do for this. It's a kind of gift for kids. Assistant, I'm a bit surprised. So there is some work to be done here, but I have a slide about Assistant. And that's the slide. How many people have seen this before?
Assistant. As I said earlier, our vision for our Assistant is to help you get things done. It turns out a big part of getting things done is making a phone call. You may want to get an oil change schedule, maybe call a plumber in the middle of the week, or even schedule a haircut appointment. You know, we are working hard to help users through those moments. We want to connect users to businesses in a good way. Businesses actually rely a lot on this, but even in the US, 60% of small businesses don't have an online booking system set up. We think AI can help with this problem. So let's go back to this example. Let's say you want to ask Google to make you a haircut appointment on Tuesday between 10 and noon. What happens is the Google Assistant makes the call seamlessly in the background for you. So what you're going to hear is the Google Assistant actually calling a real salon to schedule the appointment for you. Let's listen.
How can I help you? Hi, I'm calling to book a women's haircut for a client. I'm looking for something on May 3rd. Sure, give me 1 second. Sure, what time are you looking for around? At 12 p.m. We do not have a 12 p.m. available. The closest we have to that is a 1:15. Do you have anything between 10 a.m. and 12 p.m.? Depending on what service she would like. What service is she looking for? Just a woman's haircut for now. Okay, we have a 10 o'clock. 10 a.m. is fine. Okay, what's her first name? The first name is Lisa. Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd. Okay, great. Thanks. Great. Have a great day. Bye.
That was a real call you just heard.
Okay, I can stop this one. I can tell you 2 stories about this. One is a personal story. I'm divorced. My kids, they live in Italy. And my son, who is 17, you are probably a bit too young to understand exactly what I'm saying. But there is a moment where kids are turning from you understand everything to you don't understand anything, right? And this is where I am right now, with only 2 exceptions. One is music, because I like music. I was a DJ in the past. So Lorenzo, he kind of liked the fact that I work at Google, but he really likes that cloud is powering Spotify, because that's what he likes. And then a few days ago, he called me saying, I saw this video, I'm so proud that you work at Google, because this is really changing the life of people. I was like, wow. So I shared this story with Yossi, Yossi is the site lead, exactly my same role, in Israel. This was developed by Tel Aviv. It was actually a very, very small group of people working in Tel Aviv. And again, one of the things that I like in Google is that we actually publish what are the results. We don't publish exactly what is the network in this case, but these are two recurrent networks and a wave net to generate the sound. There is a technical blog, if you want, and go and search, where it's described at quite accurate level. It's not a scientific paper as of yet. And also, sorry, I forgot to say, also for this one, there was a technical blog describing how this was implemented. There is a link there. To me, this is another example. Apart from the fact that it was like an incredible success, unexpected from the point of view of media, because media, they like to have this type of stories. I had friends from Dubai who sent me this video translated in Arabic. But I think that the main point here is another example of real impact on life. I use Assistant every day, mostly to play music, but not only for that. I have Assistant in my house. There are certain things where there is still room for improvement, but I see this improvement coming like every day. My voice was recognized immediately without any particular training. And I remember that no more than 5 or 6 years ago, when you were using like kind of Dragon Dictate, it was like really you had to play a lot of time to train the system. Okay, I almost concluded my presentation, but I want to present one problem that we solved here in Warsaw, and then I'm open to all the questions. I cannot disclose the details, technical details, how this was done, but I want to put the problem. Lot of our customers are basically asking to us to have like scalability. And they ideally want to have something like this, which is of course very difficult to achieve, almost impossible to achieve. So if the load is increasing, then you want to have more machines that are serving your... We have a nice public post if you want to go there and check. Snapchat is powered by Google. And there is, when the Super Bowl happened, the load of Snapchat was actually totally reflecting the different moments of this Super Bowl. So it was going up and down according to with significant spikes, because Super Bowl is a kind of difficult, it's a kind of very popular. Okay. So what Google has, there is a paper, there are many papers about this. It's something called Borg. This is like, I'm not going in many details, but everything is well described. And Borg is essentially a very large distributed system working on millions of machines in hundreds of different data centers around the world. And if a machine goes down, and trust me, many machines are going down, they are immediately replaced by others. There is a federation of Borg masters that are checking what the different Borg machines are doing and assigning jobs to these machines. There is a system of tiers here. So there are jobs that are top priorities. Guess what? Search is top priority. But perhaps YouTube transcoding can be tier 1. And then we have also jobs that are T2 and the jobs that are batch. Okay, so batch type of batch computation. Of course, this is worldwide. It's not in one single. We call this one cell, and there are hundreds of thousands of different cells distributed in different data centers. Now, okay, this I can possibly skip. This is what I was saying before. Okay. So this is this is a view of some machines. One single row is one machine. in this single row, one machine, there are different jobs that are allocated. These are different customers, so there is a problem of isolation. Of course, this should be handled. Sorry, there is a problem of separation, so isolation. And guess what? This could be like the normal bin pack algorithm, but the problem is the scale here. The different colors are representing the tiers of priority. I think red in this case is like tier 0. And there are machines that are not having full use, right? And this is a problem because, of course, you want to optimize the way in which this is exactly where we are working here in machine learning in Warsaw. You probably saw the public result on data center cooling. I don't know if you saw this public result. This is another one that is truly outstanding. Because essentially, these are, sorry, just to clarify, some of them are machines that are having resources that are available, and others are things that we cannot move. Standard resources are things that we cannot move. So we have also this type of constraints sometimes, because perhaps there is a special hardware, right? So perhaps there is a TPU allocated to that particular Borglet machine. So there are some significant constraints that we need to respect. And basically, when we started to use machine learning, we had, well, that's the moment where machine learning played. The first model that was deployed gave a gain of 20% in our metrics for fleet allocation, still having the same eviction rate. Eviction rate is essentially this. The problem here in this case is you have a number of limits. You cannot allocate machines that are exceeding the capacity of the CPU. You cannot allocate to machines if you are exceeding the number of the capacity of memory, and many other limits. You make your prediction, you make your assignments, but then sometimes you actually have mistakes, right? So, and that's a moment where the machine will have an eviction. And the eviction can be like rescheduling, which has a significant cost. But the eviction can be also out of memory, and this is basically restarting completely the computation. So there are different cost functions according to the type of evictions. And so the goal there is to improve the utilization of the fleet without changing in a significant way all the metrics that we have to check the eviction. And this is a team of people working here in Warsaw, and was basically adopted worldwide by Google. It was a big result that we were able to achieve. This is my last slide. Questions? Don't push me too hard on what we did here on this last thing, please.
The last slide, how did you achieve this? And my question is, how much of it was more like business and gathering the data, and how much was a good model?
Okay, large part of it, okay, so let me clarify one thing. How we achieved this. I'm not going to disclose what type of nets we used, but I disclose a number of things. I disclose two things. One is, which are constant. One is, essentially Google has data for around 15 years, or even more, I guess, of job allocations, right? So you can, and you should, build offline models. And then you should have some proxy metric that is basically saying this is what you are able to predict offline, and this is what you expect given these best candidates generated offline when you go online. So how you achieve, first thing is training offline as much as you can, running offline experiments, which you can run in millions, or even more, probably. Generate the best candidates, and then once you have the best candidates, have some function that is actually predicting how this will behave online. And online is actually meaning running canary or A/B testing, as you want to call. Basically, put this model in production, in a cell and allocate a certain fraction of the real traffic, and then try to grow and understand what's the behavior of different cells and different tiers. This is part A of your answer, of your question. I'll give you also part B. Part B is, if you're asking, I want to understand your question. If you're asking, have you spent a significant amount of time on feature allocation, or feature selection, or what? What was exactly your question?
How much was it a big deep learning model, or could 80% be done with a simple, I don't know, a linear or logistic regression model, and the big part was only the...
Okay, I give again a generic question on purpose. I'm kind of playing a bit here, but I'm playing with things that you probably should know. First time, for this particular problems, there were no machine learning models in production. We had metrics already in place. This was important. So the first time we put a machine learning in production, actually the baseline was really very low. So a simple model was actually performing pretty well, but on specific tiers. The problem is solve this on multiple tiers, solve this on multiple cells. So the part of the answer to your question is even simple model at the very beginning worked really, really very well, as you can imagine, but on a specific subset of the problem. Any other question? Sure.
So, technical one, I'm not sure whether you can disclose or not. Do you frame this as a typical supervised machine learning problem, or would you frame it as an optimization problem? Could be single objective, could be multiple objective, but from, let's say, if I look at this, if I think of this as a multiple objective optimization problem on this kind of scale, there's very little state-of-the-art solution being available. So for me, it's interesting.
It's a very good question, and you are right. At the beginning, I said this is a beanpack algorithm problem. Right? So there are many things that where you go optimize. I totally agree. But we compared the multiple techniques, and that's what we did. So the answer is, okay, I'm running out of time. The answer is both, in reality. Sorry, I'm running out of time. Thanks a lot, guys. I hope that you have fun, and thanks for coming to.
Maybe some questions during the break.
Once again.